All right, this is the review of the first 5 student learning topics that we've covered so far. I'll post this in Google Slides and you can get a copy of it. So sorry for the poor quality of this. I imported the PDF and it didn't quite turn out like I like, but I think you can read it. You can follow along on the slides that I posted on the classroom. So this first one here, Miss Quotient gave the following question on her last math quiz. Use the verbal description below. Write the original function and its inverse. Start with the number, divide by 2, subtract 2 from that quantity. Here's James's answer. Y equal x divided by 2 minus 2, and the inverse 2x plus 2. And then Pauline's answer, y equal x minus 2 divided by 2, and the inverse 2x plus 4. So if I look at this, start with a number and divide by 2, and then subtract 2 from that quantity, this is correct. Okay, and then the inverse would be write down the x, so y inverse should be write down the x, and then the first thing I'm going to do is going to add 2, and since I divided by 2 here, then I'm going to multiply this whole thing by 2. So what James did here is he didn't use the distributive property correctly. So explain where each of them went wrong. So James's inverse is incorrect because he didn't use parentheses there. So after this first step here, x plus 2, he didn't use parentheses for the second step to let me say that again, multiply the result by 2. So let's see what Pauline did. So she started with the number and she subtracted 2 first. So this is incorrect. But somehow she got the inverse correct. So I don't know how she got the inverse correct because the first step is wrong. So Pauline original function is the wrong, she did the wrong order of operation. So she, she did subtract 2 first and then divided by 2. So wrong order. Okay. Going on to the next problem. So Hansel and Gretel went for a walk in the woods, left a trail of breadcrumbs to help them find their way back. Below are the directions they followed to the cottage made of candy. When they found out that a dangerous witch lived there, they were quick to follow their breadcrumbs out of there. What are the directions for them to go home? Uh, so from Candy Cottage, return on Gumdrop Avenue. So they made a left, then you're going to make a right on path toward bottom of the waterfall. Continue on waterfall path to cobblestone. Uh, right on the dirt path. Turn left at the oak tree. All right. All right, so just doing the starting at the last direction and work your way back up to the top there. So using these verbal description, write the original function and its inverse, explain your solution strategy with equations, symbols, or words. So the easiest thing I think is to make an equation. So f of x, you start with a number multiplied by 3, so 3x. Take the square root of that and then subtract 1. So the inverse, you can use the do and undo table here. So the undo would be add 1, square, and then divide 3. So the inverse function is x plus 1. You want to square that whole thing, and then divide this whole thing by 3. All right, if Jill used 1/2 for n value, what would the result be at the end of the process below? Explain how you would know this without be given hn. So in other words, if you plug 1/2 in here, you get some output. Plug that into the inverse, and the result is 1/2. So we know that because if this were a table of values, you would have 1/2. Whoops, let me do x and y here. X and y, you got 1/2, and then the output. And then for the inverse function, you would have the output. That's this right here. And the input of the original would become the output here. So inputs and outputs are swapped. All right, the 0.35s on the graph, what's the accordance to the corresponding point that's on the graph of the inverse? Then once again, you would swap the input and output. So you swap the x and y. Here it's 5, 3. I'm not going to do this, so we didn't go over this in class. So I'm just going to require you right now to do this. So the algebra argument would be the line segment connecting these 2 points would be bisected. Y equal x would be the perpendicular bisector of this segment connecting these 2 points. So that's one way you could prove it algebraically. But we're not going to do that because I didn't show you that. So we'll just skip that for now. All right, so here's for 6 and 7, you want to take this graph right here and then graph the inverse. So the easiest way to do that is pick off points here. So I'm going to pick off this point. It says make sure to plot points of symmetry, vertices, and at least 2 other points. So here's a point I'm going to use. Here's a point I'm going to use. And I'm going to use one more here. So this one here. All right, so the inverse point of 2, 0 would be 0, 2. So let me draw that in a different color here. Let me use orange. So 2, 0 becomes 0, 2. And then 0, 1 becomes 1, 0. And negative 2, 2 becomes 2, negative 2. Let me see if I can get the line tool here. Over here. Oh, I just hit the pad with my forearm. I can learn to understand you much better if I can get familiar with the way. I don't know what that was, so I just must have hit the voice command there. So let me get the line tool here. So if I draw a line through this here, Once we go right here. There we go. All right, so, and if I labeled the points I just used were 0, 2, 1, 0, and this point here, 2, negative 2. Maybe it would be a good idea to show you how this is a reflection over the line y equal x. So I'm going to plot that point, this one, and this one. Go ahead and get the line tool here. If I went this here. So they probably should have had you plot the inverse on the same graph here. Whoop, that's a little bit off, but if I drew the line y equal x now in blue, so that would be like this here. Do a dash line here, y equal x. Whoops, it's off a little bit, but let me just draw a solid line. It'd be easier for me to draw the solid line y equal x. All right. So the orange graph is the reflection of the black one and the line y equal x. All right. And the inverse of this, we're going to talk about the inverse of this graph a little bit more. So 0, 0 would remain 0, 0. And 1, 1 would remain 1, 1. And negative 1 would be still negative 1, negative 1. All right, so this is a little bit confusing. You're not going to draw this same thing. You might want to come here and say, well, this is about 2. So right about 2, you got 6. So you go like this here. And then on the other side, negative 2, negative 6 becomes negative 6, negative 2, or about that. And then you want to draw a graph through that. This is going to be difficult for me, but do the best I can here. So this would look like that there. What? And we didn't talk anything about domain and arrangement. We will, but you should know that the inverse, so the inverse domain would be -712 in the range. So just the domain and range would swap around here. And the range would be 410. Determine the inverse for each function. Explain how you determine your answer by using equations, symbols, or words. So we're going to go ahead and use, so the do table here would be multiply 3/2 and then subtract 4. So the undo would be, let me use different color, add 4, and then divide by 3/2, but we talked about this in class, so multiply by the reciprocal. Oh, so multiply by 2/3. So the inverse function would be, write down your x, add 4, and then multiply that whole thing by 2/3. All right, so this one, if I do the do and undo table, the first thing would be square, and then multiply by 3, and add 5. Then the undo would be starting up here would be subtract 5, and then divide 3, and then square root. So the inverse for letter B is write down my x, subtract 5, divide by 3, and then take the square root of everything. And the inverse here of h of x, so h inverse of x or inverse of h of x, you just are going to swap the x and y values here. So 0, 0 remains 0, 0, 8, -3, -3, 8, -7, -4 becomes -4, -7, 1, -1 becomes -1, 1, and why they put so many points here, I don't know. Just you get the idea of just swapping the x and y here. 3, 5, 2, 10, and 32, 100. So some of you on the Desmos activity, we're just negating these things. Don't just do the opposite. You actually want to swap the x and y values there. So this one here, x and the inverse would be -2, -1, -3, 0, -2, 1, 1, 2, and 6, 3. And then the final problem here So write a function that will help Josh determine the monthly cost of his cell phone. He gets a monthly fee of $49.99 and charged for 4.9 or $4.99 per gigabyte. So you could say that we'll say cost is equal to 4.99 per gigabyte. That's $49.99. Josh lost his September bill, knows how much he paid for the month. Write the equation that will help Josh determine the amount of data used on the phone and the total cost of bill explained. So you would do the inverse here. Equation would be C minus $49.99 divided by $4.99. So the gigabytes used would be equal to cost minus $49.99 divided by 4.99. And Josh's total bill was $109.87. How much data did he use? So G is equal to 109.87 minus 49.99 divided by 499. So let's get the calculator here. There we go. So Desmos. So let's go back here. What the heck? All right, so what are we looking at here? 108, 109.87. 109.87 minus 49.99. Let's move this out of the way. 109.87 minus 49.99. You get an answer there. And you want to take that answer. Let's see what happens if I divide. Oh, no, I don't want that. So see if I can undo that. Let's do this here. Use the divide key, get a fraction more than 109. Minus 49.99 divided by 4.99, and you get 12 there. So right here, 12 gigabytes. So how could you use the original function to check your solution? So if I plug in a 12 here, so if I did this for 99 times 12 plus 49.99 should equal 109.87. Let's see if that checks. So back on the graphing calculator. So 499 times 12 plus I get what I started with, 109.87 right here. So let's go. All right, so that's the review. Try to get through that in class. Kind of doubt if I give it some wait time for you to try them on your own that we'll get through all that. But the video's here for you to look at. So go up here. All right, so let's stop this.